Now let's just move on further, but before that we already know that in the previous classes we have used a result that the in some of the interior angles of the triangle is actually nothing but is equal to 180 degree. Now we are going to prove this particular concept under the topic which is nothing but called as the angle sum property of a triangle. Now we will prove this concept that the sum of the angles of the triangle is 180 degree. So this is the theorem that now I am going to prove. So let us suppose if I am just starting with its figure. So I have taken this figure, that is PQR being a particular triangle over here, and I have named the angles as 1, 2 and 3. So let us suppose if I am just starting with the given condition. Given is a triangle PQR with the angles angle 1, 2 and 3, angle 1, 2 and 3. So what we have to prove over here, we have to prove that angle 1 plus angle 2 plus angle 3 is 180 degree. So I'm just doing a little bit of construction over here. I'm just doing a construction over here that draw XPY parallel to QR. So here I'm doing a little bit of construction that I'm actually drawing a line that is XPY. So let us suppose this is my P, this is my P. So I'm just taking this point and this point, and I'm just actually drawing a line which is parallel to this QR. By construction I'm just taking these two this particular line which is actually nothing but parallel to this line, that is QR, and I'm calling it as nothing but XP, and I'm calling this as nothing but Y. And let us suppose if I'm just calling this particular angle as nothing but angle 4, I'm calling this as angle 4, and I'm calling this angle as nothing but angle 5. This angle as nothing but angle 5. So by construction I have drawn XPY parallel to QR. Let's just start the proof of this particular theorem. So first of all we can see that since the line XPY is parallel to the line QR, if this is parallel to QR, then we can take PQ being a transversal. Then PQ being a transversal forms alternate interior angles. It definitely forms the alternate interior angles, and we can see over here that the angle 4 and the angle 2, they are actually nothing but the alternate interior angles. It implies that angle 4 is equal to the angle 2 because they are nothing but the alternate interior angles. Furthermore, in the same way we can say that since the line XPY is parallel to the line QR, then PR being a transversal implies that the angle 5 is equal to the angle 3 because they are actually forming the alternate interior angles. They are forming the alternate interior angles. Let us suppose if I am calling 1, if I am calling it as 2. So at the end what we are getting, we are actually getting that this particular angle, that is angle 4, is actually coming out to be is equal to the angle 2, and this angle, that is angle 5, is actually coming out to be is equal to the angle 3. So I'm marking it as this in this manner. Now furthermore we know that let us suppose if I'm just writing it again, since we know that the line XPY forms a straight angle, it implies that angle 4 plus angle 1 plus angle 5 is nothing but is equal to the 180 degree because of we can say it either by the linear pair axiom, or we can also say it by a straight angle formation. We can also say it by the linear pair axiom, or we can also say that it is nothing but a straight angle. That's why their sum is nothing but is equal to 180 degree. Now from the equation number 2 and 4, we can write angle 4 as angle 2 plus angle angle 1 and angle 5 as angle 3 as nothing but is equal to 180 degrees, since we know that angle 4 is equal to the angle 2 and angle 5 is equal to the angle 3. And what we just wanted to prove over here, that angle 1 plus angle 2 plus angle 3 is nothing but 180 degree, which is nothing but the proof of this theorem. So hence proved that the sum of the angles of a triangle is nothing but is equal to 180 degree.